Okay, last time we actually stopped here. So what is a bill of material? It is the collection of components that make up one unit of a product. That product can be a finished good, or that product can be a semi-finished good. And the bill of material contains everything to make one unit. So over here we have the example of a motorcycle which needs two assemblies. Now these are assemblies, top level, these are assemblies. Assemblies, of course, it's a phase in production, and in two parts a motorcycle is produced. So the powertrain needs a motor, an engine, the gearbox, and the exhaust. Well, the chassis, people call it chassis, but it's called chassis. That requires the frame, the brakes, the rear wheel, front wheel. So bill of material is a complete, formally structured list, not process, but list of uh, the components of a product or assembly. A bill of material contains a description of each component. It will contain the description, the quantity, how many of brakes will be needed, how many of rear wheels will be needed, and a unit of measure. Measure means like a measure will be like in kgs or each or number or liters, okay, or units, okay. A bill of material creates a relationship between an assembly and all of its direct components. So this is an assembly, and the relationship is direct over here because these are the components. Now, components is basically ingredients to make something, but this does not actually show you how the motorcycle is made. Okay, this will not actually show you the process, but it's just a list of the components. Okay, now for example, let's make it more simpler. We want to produce a pen, one piece. So for that pen to be produced, we need some components, some elements, some more products or items. Those items are M101, which is in our factory, or in our enterprise, or in our company, it is called M101, but in description it is called refill. We need one piece. The stem, that is M102. This is the code we have given. For example, it can be C102 or F102 or whatever. One piece. Cap, we need one piece. Bottom cap, we need one piece. Bolt, we'll need 4 pieces. So these are list of components to make a product, but not the process. Like what will come first? What will be the process of making or assembling a cap, or what component will be the first? Okay, the first component can be the bolts or the refill. Okay, that is not shown here. Is just a plain bill of material. Okay, so if we talk about bills of material, there are several categories. Material BOM that we were just discussing right now, like this or this. Okay, then we have a sales order BOM. Now sales order BOM is basically needed when we are going to produce a certain amount or a certain product based on the sales order that has been placed by a customer. And this is usually done when your production is basically started based on the sales order. This can be any industry. It can be automobile, it can be textile, because a customer will place an order that he wants, for example, 100 sheets or bedding accessories. So you'll place an order, and based on that sales order, we'll create a production order, and on that production order, we will have bills of materials prepared. Okay, standard BOM, which is again a plain standard BOM. Material BOM is basically you want to create a certain material, can be a finished good or semi-finished good. Now, a document strategy. Now, what is a document strategy? I'll come to this later on. Equipment BOM, you want to make an equipment in industrial setup. For example, that you are into making of industrial cutters. Okay, this is so very ideal in industries like spare parts industry, for example, tractor industry. And tractors will actually require cutters for seasonal cutting of their crops. So if your crop is rice paddy field, the cutter or the excavator or the pulling process will need a cutter or a puller, which will be different. Okay, so you will manufacturing a cutter, for example, which will have a different configuration. For example, that will be smaller because your rice paddy is small in size. Okay, and that equipment you'll make in your factory and supply to the tractor owners or the farmers. Okay, now in the same area, in the same location, in the same scope, there's another season of bamboo, not bamboo, sugarcane. Sugarcane will require cutting, for example, and that cutting will be different from a rice paddy field. Then the equipment that you will require will be different. So equipment BOM is that you're making industrial equipment. And this is also very much unique for customized orders. For example, like private planes. If you are manufacturing private planes, you'll need engines of different configuration, right? And based on that, of course, every customized airplane will have different furniture, engines, accessories, model, airplane model, okay, model type, right? Based on that, you'll manufacture equipment. Functional location BOM. Now, the functional location, this is coming from the service industry. Okay, the functional location will mean that, for example, you have an industry which is service based. Okay, for example, you are into construction. Construction is part services, like architecture is part services, part operational. Okay, and that, of course, you need, for example, you are into architecture, you'll need a BOM. For example, you want to make a bridge. A bridge will have components. Okay, that components will first require an architecture approval, and designing, drawing, drafting, engineering. Engineering will steel structure engineering, and then you'll need forecasters. So in that way. Okay, again, document strategy is also the same, where you are actually creating something related to a machinery, for example. Okay, that machinery requires special a special how would you say, how would you put that, uh, special operating. I mean, you need a special operator to do that. Okay, a machine that requires special operators, like, for example, a nuclear reactor. I know this is a little bit odd example, but of course, a nuclear reactor or a hydraulic system or a hydrant system will require certain steps that will be followed by the operators, specifically with the steps and SOPs. So that also is, so BOMs can also be made for making user manuals. So BOM prerequisites, what are the prerequisites? Of course, for that we need material master. A material master will require a location, a plant, okay, area of validity, so that you can make a material BOM, because a material BOM will need an area of validity. An area of validity is nothing but a plant, and that plant will require master data of material which is available over there, so you can actually stock the material and make that material BOM. So BOMs deal with data that is directly relevant to production. From this comes the area of validity. Validity area is this. It is a place of work where all necessary preparations for work are made. For example, planning material requirements and creating routings. Now, routings is basically the process. This is bill of material, and how to make a motorbike or a pen is actually explained by routings. If you want to create a material BOM, there must be a valid material master in the same plant. Many checks are also take place when creating items. If you create material components, then plant data must exist for the materials. Okay. Okay. I'll start another presentation. Just stay with me. And okay. So bills of material. Yeah. Bills of material. We've already seen this. BOM prerequisites. Yeah, BOM allocation in plants. So BOM allocation basically is that you are creating one semi-finished good or a finished good, and you have created a bills of material, but some of the material will be sourced and used at plant one. The other one is coming from plant two. This is very ideal for automotive plants, where the chassis, for example, the chassis will be assembled at this place. The powertrain of the bike will be assembled at this place, and that will actually be collected in the material bills of materials. So we assign area, and this area is area of validity to a particular bills of material. So material bills of material, okay, is basically a list of all the materials like these, and the quantities are mentioned. For example, gears, seat, bearings, seat support, all is mentioned over here, but this is not the process, but just a list. So it contains essential basic or master data for integrated materials management and production control. Okay. The bills of material results from the production design phase drawings. The bills of material results, it comes from the product design phase drawings that the engineer pass a design, and then based on that, a BOM is made, and a list of all the parts required, and a list of all the parts. Now, all these parts are required to produce a product. So components are required to accomplish by production. Now, these are the components. Okay. And bill of material consists of unit quantity required, these quantities, material list, and description. This is a description to produce one bike. Complete list of formally structured components. Complete list. I mean, this is what is actually going into assembly or production to make one bike. To make a product which can be assembly or finished product. It contains material numbers. Okay. Single level BOMs are basically simplified, and it tells you two assemblies will be there. No molecular details are available in a single level BOM, because in single level, it creates the relationship between assembly and all its direct components. So motorcycle has two components, which is powertrain and chassis, and that is basically a single level BOM. So it's basically establishing a relationship. It combines both, that both powertrain and chassis will be combined and the bike will be produced. So drill down molecular details are not available. Multi-level BOM is basically, multi-level BOM basically goes down into details as to what basically comprises of an assembly and what is going into an assembly and what is in the chassis. Okay. It combines single level BOMs and creates a complete multi-level representation. So different assemblies have components, molecular details to produce a bike. So there are categories like material master record, equipment master record, and document info record. A bill of material can only be created for an object that has a material master record in the system. So you should have a material master maintained, okay, if you want to create a material BOM. The BOM category determines whether the BOM is created for a material, equipment, or document. As I said, you want to create an equipment for industrial purposes, okay, that will actually require certain equipment, bills of materials to be made, and the master record of that equipment has to be there in the system. Material BOMs are used to represent structure of the products manufactured. So document BOM, as I have told you, it's basically series of steps required for a service to be rendered. Validity periods. Now, every BOM, yes. Now, where is this ideally suitable for? It's suitable for automotive industry, for example, where new models of the car are valid for 1 year. Yeah, new models are rolled out, and the validity of that is then decided whether that model will run for 1 year, 2 year, or some months, maybe 5 years, 6 years, right? So there is a start date. It can be a future date as well, or a past date, or current date. And validity for the next is basically depend on the business performance of that product. Validity area is nothing but the plant, and some material will be made at different location, and some materials will be made at another location, and that will be comprised in the material BOM. The validity area validity and the validity period defines the precise conditions under which a bill of material applies in different areas of a company. Okay, a validity area defines which plant may use or produce an item described by a bill of material. By linking the same bill of material to assemblies or components in different plants, you can extend the bill of materials validity area. So one material can be extended to another plant if it is required. An assembly or component may have a different bill of material for various validity areas. So that means that some material, for example, is being used for this material BOM, like 50 kg is being, but this combination of materials is also using 20 kg at some other place, which is possible. BOM execution, how it is used. It is used for production orders, and in production orders, you actually do costing. Okay, you do costing, you do quantity planning, you do production planning, just to see how much of a material will be used to produce a certain batch or a certain stock or a certain finished good or whatever. The components from production bills of material copied to the production order or run schedule. Run schedule is used for repetitive materials. These components can then be changed if necessary based on the actual production requirements. Now, actual production requirements says that you need 1 chassis, 4 bolts, 1 seat, 2 covers, 2 brakes. But for example, if you know that your production machine or your assembly machine can scrap a certain percentage, like 2% of all the stock, then you will add more of that. Every component that can be scrapped or broken or damaged, you will add 2%. So instead of using 100 pieces, you will use 102, so that you can produce 100 pieces. So types of bills of material. Now, types can be different. Simple BOM, although it is multi-level, but simple BOM means that you are creating a pen, and the pen process is going to remain the same for the next 5 years, 6 years, 8 years, right? And you don't have any other variant. Okay, for example, you have ballpoint pen. Ballpoint pen process will usually remain the same, and if that is a high selling pen in your factory, you will keep producing that in the same process, and it will be hard coded, for example. Variant BOM and multiple BOM. Now, what is multiple BOM and what is variant BOM? I'll first explain what is multiple BOM. Now, multiple BOM, for example, you're making the same pen, okay? For your local market, the pen quality will be different than for the American market. Okay, I mean, it happens, right? Your plastic grade, your ink grade, your cap grade, your plastic granule grade, your color grade will be different. So material alternative for your local market is different, and material alternative for the foreign market, for the US market, will be different. So that's how you can interchange. If you're making something for the US market, you will actually use the same alternative. This can be a better alternative, and this can be a normal alternative to make the same thing. And that actually becomes a multiple BOM. Or in another case or use case, it is that, for example, you are making a pen, but you get a customized order from the local market, but it says that, yes, we want to have more ink, more weight of the pen, or lighter weight, whatever, then you actually have a material alternative for that customized order. Variant BOM, for example, is the same thing like simple BOM, but there is a variance or a difference in configuration or specs, not configuration, but specs. Specs like whether the bicycle or the bike will be blue or white, whether the seat will be blue or white or black, whether the body will be white. That, I mean, there is no difference between simple and weight, but that, yes, there will be a difference just between the colors, the scheme. Overall, it will just remain the same. So simple BOM is one way of doing things. Variant is different variant sets, configurations remain same. Multi-BOM is basically alternate available to create same material and finished product, but of course, with a little variation in the weightage or grading or potency, right? So what is a BOM structure? Now, BOM structure is something where you actually list down the items. Okay. At the header level, you actually tell that what is the status of the BOM, whether you have these items. Now, the items we have already discussed is this. These are the items. These are the items. Okay. If I go down, yeah. And item, these are the same items that we were like chassis, gears, seat, brake pads, covers, and exhaust. These are items. What is sub item basically? Sub item is basically the positioning of an item. For example, yeah, we need 4 quantity of bearings. So bearings will be needed at various positions, like at the front wheel and the back wheel. Okay. And you need bearing for the handle. Of course, you have to rotate that, right? For brakes and for acceleration. Okay. And you need bearings for the shocks, right? Over there too, you will need some bearings. Yeah. So sub item is basically not basically defining the main item, not defining the seat, not defining the brake pads, but sub item is basically the position. Sub item look the same, but positioning on the product is different. Now, for example, CD70, the bearing position will be a little different. By positioning, I mean that it's 2 centimeter apart, but in YBR 150, the bearing position will be, or bolt position will be like 200 centimeter or maybe 60 centimeter based on the position. Yeah. So that is sub item. So there are categories. When you create a new BOM, you must assign each component to an item category. Now, what is item category? There are various items: stock item, non-stock item, variable size, text, document, class item. Now, what is a document item? Let's talk about this first. This is non-materialistic material which is required to produce a product, like drawing, document, specs, user manual. So you can actually classify something that this is a user manual used to produce a bike. So you can have a document BOM to actually specify how or what components will be needed to produce an equipment or a bike. Stock item is basically items that will be pulled from the stock to produce a good, like your material, raw material. Okay. Non-stock item is a material but not kept in stock, like grease or project managers advice or inspection. These are part of the process. For example, you are assembling a bike, you're assembling the bike, and during the assembly of the motor, the quality inspector has to come and check whether whether the motor is fitting properly, it is making the right noise or not, the knocking, and he will be using, that's part of the inspection team, right? But that is just not that is a non-stock item, you cannot stock that. Okay, variable size item, for example, if you're making mud guards for that bike, okay, so, and those mud guards are created from iron sheets, okay, but you do not know how much of the iron plates or sheets are required, okay, and sometimes it may be they are required more and sometimes they are required less. Why less? Because during production, for example, you're working on a machine that by daytime it's working fine, but after a certain limit of after like 8 hours, it starts to consume more iron plates. Why? Because the machine is actually working over limit. So in that, of course, you actually assess that the item should be variable size, because your machinery is such that after 8 hours it will start consuming more of this. So you'll have items like iron sheets for making mud guards, okay, and you will classify it as variable size item. Text item, handling instructions. Now text item, again, similar to document, but in text you actually give instructions how to handle various components, how to manufacture, or how to, for example, like handling a motor at that this motor has to change gears at 200 degrees centigrade. When that is done, then only you can fit a gear. I mean, these are text items. Class item. Now, class item, what is this? Now, class is basically that you're creating a bike, but now classes are there. Red bike, blue bike, black bike. Now, these are classes. Those colors will be classified or categorized into those classes. Okay. So from the next class, we'll actually go and check, because right now we are out of